Some are saying yes, some are no. It's okay. Okay. So we will begin with the class. Capacitor. Formulas ಮತ್ತೆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ನೋಡ್ತಾ ಹೋಗೋಣ. ನಿಮ್ಗೆ ಬೇರೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋಣ. ಅದರ್ವೈಸ್ derivation we will not focus much here. We will discuss that. So first one, electric potential. What do you mean by electric potential? What is the formula for that? For the potential? Let's see. So this electric potential is denoted. Potential is denoted V. So ಯಾರಿ ಕಾಲೇಜ್ ಅಲ್ಲಿ ಆಗಿಲ್ಲ ಅವ್ರಿಗೆ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ ಆಗುತ್ತೆ. ಸೊ ಬೆಟರ್ ವಿ ವಿಲ್ ಗೋ ಲಿಟಲ್ ಸ್ಲೋ ಓದಿ, ಇಲ್ಲ ಅರ್ಥ ಆಗಲ್ಲ. ಪೊಟೆನ್ಶಿಯಲ್ ಇಸ್ V. So this electric potential is defined as it is the amount of work done. See, for example, if you consider any one charge is there at infinity distance. Okay, so I have one charge here which is at the infinity distance from this one particular system. I want to bring this charge from infinity to this system. Okay. Suppose here the system is consisting of positive charge and your infinite charge is also positive. ನೀವು ಯಾವಾಗ ಇದನ್ನ ಇಲ್ಲಿ ತರಬೇಕು ಅನ್ಕೊಂತೀರಾ, that time here the force of repulsion will be there between the charges. ಹೌದಾ? So you need to do some external work done here. That external work done per unit charge what you are doing, this is called as what? Electric potential. So what is electric potential? The amount of work done per unit charge is called as what? Electric potential. So this electric potential, the SI unit of this electric potential, it is volt. The electric potential is a scalar quantity. The electric potential at infinity distance. So electric potential at infinity distance, it will be always 0. Then this electric potential, it is independent of the path followed by the charge. It is independent of the path followed by the charge. So these are the 5 points regarding the electric potential. You remember the electric potential is given by work done per unit charge. The SI unit is volt. It is a scalar quantity. At infinity, the electric potential value is 0 and it is independent of the path followed by the charge. So note down whatever the points you require. Then next we have the potential difference. So what is this potential difference? Suppose if you consider a system and this system is consisting of two charges. Okay, so here I have one charge and here I have the other charge. This is my point A, this is my point B. Here whatever the difference in the potential is there, andre potential at V at A minus the potential at B is called as what? Potential difference, and it is given by the work done between AB per unit charge. So this is what? The potential difference. The potential difference is given by work done per unit charge. The potential difference is given by the potential differences VA minus VB, means between the two particular points. Okay. So this is regarding electric potential, then the electric potential difference. So just main points we are discussing, and here we have the electric potential due to a point charge. So now we just a basic definition nodidvi. The electric potential is given by work done per unit charge anta. So due to the point charge, what is the expression? So now we again ಮಾಡ್ತೀವಿ one fixed charge Q anta consider ಮಾಡ್ತೀವಿ at point O. I have one more charge of 1 coulomb at point A. I want to bring this 1 coulomb charge to the point P. So ನಾನು ಇದು 1 coulomb charge ಅನ್ನ point P ಗೆ ತಗೊಂಡು ಬರಬೇಕಾದ್ರೆ here 1 coulomb charge from the O point, this is at a distance of x. I want to bring this 1 coulomb charge to the distance of r. I want to bring it to the distance of r. So directly I cannot bring from A to P. So directly tarlik baralla. First now in madbekagatre, we need to bring it to the small distance first, that is to the distance of point B at a distance of dx. Okay, so this is the figure explanation. Consider a charge Q at point O. Consider 1 coulomb of charge at point A at a distance of x from the O. I want to bring this 1 coulomb charge to the point P at a distance of r from the O. So here we need to displace it first to the small displacement, that is dx. Aita. Now with derivation yav tara ಮಾಡ್ತೀವಿ? Here first we will start with work done is equal to force into displacement dx. So force we will substitute it from the that is Coulomb's law. Enide 1/4 pi epsilon naught q1 into q2 upon r square. So il r square a point ಎಷ್ಟು distance ಅಲ್ಲಿ ಇದೆ, x square ಅಲ್ಲಿ ಇದೆ with respect to dx. So q1 q2 value substitute ಮಾಡ್ಕೊಳ್ಳಿ. q1 is q, q2 is 1 coulomb. ಹೌದಾ? So q1 is q and q2 is 1 ಅಂದಾಗ ಏನಾಗುತ್ತೆ ಇದು ಎಕ್ಸ್ಪ್ರೆಷನ್ q into 1 ಅಂತ ಆಗುತ್ತೆ. So therefore ನಾನು ಏನು ಬರಿಬಹುದು ಇಲ್ಲಿ? I can only write it as q. So it is q divided by x square. Now what I'll do, I'll integrate this equation. So ನಾನು ಇದನ್ನ integrate ಮಾಡ್ತೀನಿ. Integrate ಮಾಡಿದಾಗ 1/4 pi epsilon naught ಹೊರಗಡೆ ಬರುತ್ತೆ. This q will also come outside. Then this x square we will integrate with respect to x raised to -2. ನಾನು ಇಲ್ಲಿ limit range ತಗೊಂತಾ ಇದೀವಿ from 0 to r distance. Okay, so from 0 to r distance. So after integration, after simplification, ನಾನು ಇಲ್ಲಿ direct ಆಗಿ expression ಬರಿತಾ ಇದ್ದೀನಿ. The potential due to the point charge is given by 1/4 pi epsilon naught q divided by, it will come r, 1/4 pi epsilon naught q divided by r. Okay, I hope it is clear. ನಿಮ್ಗೆ ಯಾವ್ದಾದ್ರು ಪಾಯಿಂಟ್ಸ್ ರಿಪೀಟ್ ಬೇಕಂದ್ರೆ ಕೇಳಬಹುದು ಇಲ್ಲಿ. So we will start it from the work done, then we will substitute Coulomb's law formula, then we will simplify this equation. Okay, so in this case ಇಲ್ಲಿ ನಿಮ್ಗೆ ಕೆಲವೊಂದು ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ಬೋದು. ಇಲ್ಲಿ ನೋಡಿ, the Coulomb force is given by 1/4 pi epsilon naught q1 into q2 upon r square. Then electric field is given by 1/4 pi epsilon naught q by r square. Then the electric potential is given by 1/4 pi epsilon naught q divided by r. Okay na? So note down these points. So force, field ಮತ್ತೆ potential formula ಇಲ್ಲಿ ಒಂದೇ ಕಡೆ ಬರ್ತಿದ್ದೀನಿ. You can note down this. ಯಾಕಂದ್ರೆ ಲೆಸನ್ಸ್ ಕಂಪ್ಲೀಟ್ ಆದ್ಮೇಲೆ ಫಾರ್ಮುಲಾಸ್ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಫೋರ್ಸ್ ಅಲ್ಲಿ q1 q2 by r square ಬರುತ್ತೆ, ಫೀಲ್ಡ್ ಅಲ್ಲಿ q by r square ಬರುತ್ತೆ, ಪೊಟೆನ್ಶಿಯಲ್ ಅಲ್ಲಿ q by r ಅಂತ ಬರುತ್ತೆ. We'll go for the next point. Here similarly, if I have the minus q charge, another minus q charge idre, the electric potential is given by 1 upon 4 pi epsilon naught minus q upon r. It is minus q upon r. The potential is given by 1 upon 4 pi epsilon naught minus q divided by r. This is the potential due to minus q charge. Okay. Similarly, if I have in between the two charges, so ಇದು ಎರಡು ಚಾರ್ಜ್ ಮಧ್ಯದಲ್ಲಿ ಅಥವಾ ಇದು ಎರಡು ಚಾರ್ಜ್ ಏನಾದ್ರು dielectric medium ಅಲ್ಲಿ ಇದ್ದಾಗ, so it is dielectric medium, we will see it later. So if the ನಮ್ಮ ಹತ್ರ air medium ಅಲ್ಲಿ ಇಲ್ಲ ಎರಡು ಚಾರ್ಜ್ dielectric medium ಅಲ್ಲಿ ಇದೆ, so when these two charges are there in the dielectric medium, that time the electric potential due to the medium is equal to the potential due to air upon k anta barutte, where k is called as dielectric constant, where k is called as dielectric constant. Yes. So note down this also, the relation between the potential due to medium, due to air and due to the dielectric medium, the relation. Okay. Next. So the next point is, that is the electric potential due to a system of charges. So suppose if you consider this point P surrounded by the charge Q1, Q2, Q3, like that, n number of charges, the electric potential for the system of charges, it is given by, it is 1 upon 4 pi epsilon naught summation of I is taking the value from 1 to n. It is Qi divided by Ri, Qi divided by Ri. Okay. So this is the potential due to the n number of charges. Okay. So take down this formula also. Next, let us go for the next point. That is the potential due to a dipole. So ನೀವು ಇಲ್ಲಿ ನೋಡಬಹುದು ಆಯ್ತಾ. So electric field ಕಲಿತಿರಬೇಕಾದ್ರೆ you will study the electric field intensity for the dipole. Suppose ನಿಮ್ಗೆ ಇದು dipole ಅಂತಿದ್ದಾಗ ಇದು point P ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ, along the axial line we derive the electric field intensity 1 upon 4 pi epsilon naught 2p upon r square ಅಂತ ಬರುತ್ತೆ. Similarly for the equatorial line ಅಂತ ಎರಡು derivations ಮಾಡ್ತೀವಿ. But potential derivations ಮಾಡಬೇಕಾದ್ರೆ we will not do two times. ನಾವು ಇಲ್ಲಿ ಒಂದೇ expression ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. Later we will substitute the value of theta for axial. Axial ಅಂದಾಗ ಏನಾಗುತ್ತೆ, along the axis ಬರುತ್ತೆ. Therefore theta value 0 ಅಂತ ಆಗುತ್ತೆ. Then equatorial point ಅಂದಾಗ theta will be 90 degree. ಹೌದಾ? So we will substitute the value of theta as 0 and 90 degree. So in general the derivation we will do. Now ಏನ್ ಮಾಡ್ತೀವಿ, we will consider the dipole here. So one is minus q and one more is the plus q. We consider some arbitrary point P. We consider some arbitrary point P here. So this point P, it is at a distance of r. Point P is at a distance of r. This is making angle theta from the center of the dipole. So this is the dipole length. Yes. So if I am not considering perpendicular agi illi consider ಮಾಡ್ತಾ ಇಲ್ಲ. So some arbitrary point ade along the axis illa at the equatorial kuda illa. So here somewhere arbitrary point P I am considering. So now we again ಮಾಡ್ತೀವಿ, ಈ derivation ಮಾಡಬೇಕಾದ್ರೆ we will join this from minus q charge, from plus q charge we will join this Similarly, we will also join one perpendicular line from plus q charge. We will also join plus minus q charge ಇಂದ ಕೂಡ ಒಂದು perpendicular line ಅನ್ನ draw ಮಾಡ್ಕೊಂತಾ ಇದ್ದೀವಿ. Okay, so these are the two lines here, perpendicular lines. Yes. So what we will do here, we will calculate the potential due to minus q charge, the potential due to plus q charge. Next, potential due to both the charges v1 plus v2 ಅಂತ calculate ಮಾಡ್ತೀವಿ ಆಯ್ತಾ. So potential due to minus q charge ಏನ್ ಬರುತ್ತೆ, 1/4 epsilon naught q divided by the distance. Similarly, due to plus q charge, 1/4 epsilon naught minus q divided by the distance. Yes. So ಆ ತರ substitute ಮಾಡಿ derivation complete ಮಾಡಿದಾಗ we will get equation potential V is equal to 1/4 pi epsilon naught P cos theta divided by R square. 1/4 pi epsilon naught P cos theta divided by R square. This is our formula. Okay. So ನಾನೀಗ axial line ಅಂದಾಗ theta is equal to 0 substitute ಮಾಡ್ತೀನಿ. So cos 0 ಎಷ್ಟಾಗುತ್ತೆ? What is cos 0? So cos 0 is 1. So yes, Kaveshri. So cos 0 is 1. So 1 ಅಂತಂದಾಗ it will be 1/4 pi epsilon naught P divided by R square ಅಂತ ಬರಿತೀವಿ for the axial line. Then ನಾನು ಈಗಷ್ಟೇ ಹೇಳಿದೆ equatorial line ಅಂದಾಗ theta is equal to 90 degree ಆಗುತ್ತೆ. So cos 90 is 0. ಹೌದಲ್ಲ? So cos 90 is 0, therefore the potential will be 0 at the equatorial line. ಅರ್ಥ ಆಯ್ತಾ? ನಾವು ಯಾಕೆ separate ಆಗಿ ಕೇಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇಲ್ಲ ಅಂತ, because some arbitrary points consider ಮಾಡಿ ನಾವು ಇಲ್ಲೇ ನಾವು theta values substitute ಮಾಡಿ we can calculate due to equatorial line and the axial line. So this is the electrostatic potential due to a dipole calculate ಮಾಡಿದ್ವಿ. The next point we have equipotential surface. Equipotential surface here, students. Equipotential, as the term indicates, equi andre equal anta agate. The potential is nothing but potential itself. So equipotential means equal potential. So equal potential andre enu, for example, if I consider this one particular surface, e point alli potentials matte e point alli potential, e point alli, at each and every point on the surface, if the potential value is same or the potential value is equal, then it is called as what? Equipotential surface. So what is equipotential surface? The potential at each and every point on the surface it is equal, then it is called as what? Equipotential surface ಅಂತ ಹೇಳ್ತಾರೆ. ಅರ್ಥ ಆಯ್ತಾ? What is equipotential surface? ಅಂದ್ರೆ for example, ಯಾವ್ದಾದ್ರು surface ಅನ್ನ consider ಮಾಡಿದಾಗ the potential at this point, for example 2 volt, the same potential we will have at this point also. At this point also it is 2 volt, at this point also it is 2 volt. The potential is same at each and every point, then it is called as what? Equipotential. Is it clear what is equipotential? Okay, so now we have some of the properties of the equipotential. ಏನಪ್ಪಾ, that is here first property is what ನೀವು ಇಲ್ಲಿ ನೋಡಬಹುದು. First property, the first one is here, never two potential surfaces will intersect with each other. ಅಂದ್ರೆ ನಿಮ್ಮ ಹತ್ರ ಇದೊಂದು ಸರ್ಫೇಸ್ ಇದೆ, ಮತ್ತೊಂದು ಸರ್ಫೇಸ್ ಇದಿದೆ. ಸೊ equipotential, ಇದ್ರದ್ದು potential for example 2 volt ಇದೆ, ಇದ್ರದ್ದು potential for example 3 volt ಇದೆ. These two surfaces never intersect with each other. ಯಾಕೆ ಹೇಳಿ? Because ಇದು ಒಂದು ಸರ್ಫೇಸ್ 2 volt ಅಂತ ಇರುತ್ತೆ, ಮತ್ತೊಂದ್ರದ್ದು 3 volt ಅಂತ ಇರುತ್ತೆ. ಇದು ಎರಡು coincide ಆದಾಗ, so when these two surfaces will coincide with each other at the point of coincidence, so ಎಲ್ಲದು coincide ಆಗುತ್ತೆ, ಎಲ್ಲಿ ಜಾಯಿನ್ ಆಗುತ್ತೆ ಅಲ್ಲಿ potential ಎಷ್ಟು ಅಂತ ಹೇಳ್ತೀರಾ? ದಟ್ ಇಸ್ 3 plus 2 5 ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಆಗತ್ತಾ, ಅಥವಾ 3 minus 2 1 ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಆಗತ್ತಾ, ಅಥವಾ 2 ಅಂತ ಹೇಳ್ತೀರಾ ಅಥವಾ 3 ಅಂತ ಹೇಳ್ತೀರಾ? So what is the potential value here? When the two surfaces are coinciding, what is the potential there? You cannot say it as 5, you cannot say it as 1, you cannot say it as 3 also, 3 2 also. ಯಾಕೆ ಹೇಳಿ? ಯಾಕಂದ್ರೆ ಎರಡು ಸರ್ಫೇಸಸ್ ಪೊಟೆನ್ಶಿಯಲ್ ಬೇರೆ ಬೇರೆ ವ್ಯಾಲ್ಯೂಸ್ ಇರೋದ್ರಿಂದ when they are coinciding, at the point of coincidence we cannot say what is the value. So if you say what is the value there, then it's not a equipotential surface. ಅದನ್ನ equipotential surface ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಯಾಕಂದ್ರೆ ಇಕ್ವಿಪೊಟೆನ್ಶಿಯಲ್ ಅಂದಾಗ ಆ ಸರ್ಫೇಸ್ ವ್ಯಾಲ್ಯೂ 3 ಅಷ್ಟೇ ಇರಬೇಕು, ಮತ್ತೊಂದ್ರದ್ದು 2 ಅಷ್ಟೇ ಇರಬೇಕು. ಎಸ್, ಸೊ ಇಲ್ಲಿ ಅಟ್ ಒನ್ ಪಾಯಿಂಟ್ ವಿ ಕ್ಯಾನ್ ನಾಟ್ ಸೇ ಇಟ್ ಆಸ್ 5. ನೀವು 5 ಅಂತ ಹೇಳಿದ್ರಿ ಅಥವಾ 1 ಅಂತ ಹೇಳಿದ್ರಿ, ಅದು ಇಕ್ವಿಪೊಟೆನ್ಶಿಯಲ್ ಸರ್ಫೇಸ್ ಆಗುದಿಲ್ಲ. ಗೊತ್ತಾಯ್ತಾ? ಸೊ therefore never two equipotential surfaces intersect with each other. First point. Second point. So where the electric field is strong, ಎಲ್ಲಿ electric field strong ಇರುತ್ತೆ, the equipotential surfaces are placed closely with one another. So equipotential surfaces will be closely spaced with one another when we have the strong electric field. Third point, so very important point, third point, that is the electric field is always normal. For example, this is my equipotential surface. The electric field lines will be always normal to this equipotential surface. ಅಂದ್ರೆ ಯಾವಾಗೂ ಅದು 90 degree ಅಲ್ಲಿ ಇರುತ್ತೆ, perpendicular to the surface. It is always perpendicular to the surface. Then the fourth point, work done in moving a test charge from a one point of equipotential surface to the other is 0. So first point, never intersect. Second point, it is placed closely where there is strong electric field. Third point, it is always normal to the surface. Fourth point, work done in moving a test charge from one point to other point, it is 0. ಯಾಕೆ ಹೇಳಿ? ಸೊ ನೀವು ಒಂದು ಇಕ್ವಿಪೊಟೆನ್ಶಿಯಲ್ ಸರ್ಫೇಸ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಆಯ್ತಾ, ನಾನು ಇಲ್ಲಿ 2 ಪಾಯಿಂಟ್ಸ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. ಇದು ಎ ಪಾಯಿಂಟ್ ಅಂತ, ಇದು ಬಿ ಪಾಯಿಂಟ್ ಅಂತ. ಎ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಪೊಟೆನ್ಶಿಯಲ್ 3 ವೋಲ್ಟ್ ಇರುತ್ತೆ, ಬಿ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಷ್ಟಿರುತ್ತೆ ಸ್ಟೂಡೆಂಟ್ಸ್? 3 ನೇ ಇರುತ್ತೆ. ಯಾಕೆ ಹೇಳಿ? ಇಟ್ ಇಸ್ ಇಕ್ವಿಪೊಟೆನ್ಶಿಯಲ್ ಸರ್ಫೇಸ್. ಸೊ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಯಾವ ತರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ? ದ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇಸ್ ವಿ ಎ ಮೈನಸ್ ವಿ ಬಿ. ಸೊ ವಿ ಎ ಮೈನಸ್ ವಿ ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್? ವರ್ಕ್ ಡನ್ ಬೈ ಎ ಬಿ ಅಪಾನ್ ಚಾರ್ಜ್ ಕ್ಯೂ. ಸೊ ವಿ ಎ ಮೈನಸ್ ವಿ ಬಿ ಎಷ್ಟು ಬರ್ತಾ ಇದೆ? 0. ಸೊ therefore your work done is also 0. Clear? I hope the 5 points are clear to you. Sorry, 4 points are clear to you regarding the properties of the equipotential surface. Okay, I'll go for the next point. Yes, this is electric potential energy for 2 point charges. ನಿಮ್ಗೆ ಈಗ electric potential energy ಅಥವಾ electric potential for 1 point charge you know, that is 1/4 pi epsilon naught q by r ಅಂತ ಗೊತ್ತಿದೆ. Now the potential energy for the two system of charges, ಅಂದ್ರೆ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ನಿಮ್ಮ ಹತ್ರ 2 ಚಾರ್ಜ್ ಇದೆ, ಒಂದು q1 ಅಂತ ಮತ್ತೊಂದು q2 ಅಂತ. Okay, so now the electric potential energy is given by, here when you have two charges, so ಇಲ್ಲಿ ಯಾವ ರೀತಿ ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳ್ತೀವಿ ಅಂತಂದ್ರೆ, ಇದೊಂದು XY ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ನಮ್ದು ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಯಾವ್ದು ಚಾರ್ಜ್ ಇಲ್ಲ. ಸೊ ಇನ್ಫಿನಿಟಿ ಡಿಸ್ಟೆನ್ಸ್ ಇಂದ ನಾನು Q1 ಚಾರ್ಜ್ ಅನ್ನ ತಂದು ಇಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಆಯ್ತಾ? ಸೊ Q1 ಚಾರ್ಜ್. ಸೊ ನಾವ್ ಇಲ್ಲಿ ಏನ್ ವರ್ಕ್ ಡನ್ ಮಾಡ್ತೀವಿ? ದಟ್ ವರ್ಕ್ ಡನ್ ಇಟ್ ಇಸ್ 0. ವೈ? ಬಿಕಾಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಅಲ್ಲೇನು ರಿಪಲ್ಷನ್ ಅಟ್ರಾಕ್ಷನ್ ಏನು ಇಲ್ಲ. ಸೊ ಡೈರೆಕ್ಟ್ಲಿ ನಾವು ಆ ಚಾರ್ಜ್ ಅನ್ನ ತಂದು ಅಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡ್ಬೋದು. ಬಟ್ ವೆನ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ Q2 ಚಾರ್ಜ್, ಸೊ ಯಾವಾಗ ನೀವು Q2 ಚಾರ್ಜ್ ಅನ್ನ ಇಲ್ಲಿ ತಂದು ಇಡ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಇಲ್ಲಿ ಆಲ್ರೆಡಿ Q1 ಇರೋದ್ರಿಂದ ಪ್ಲಸ್ ಇದ್ರೆ ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ, ಮೈನಸ್ ಮೈನಸ್ ಇದ್ರೂ ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ. ಸೊ ಪ್ಲಸ್ ಮೈನಸ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ? ಅಟ್ರಾಕ್ಷನ್ ಆಗುತ್ತೆ, ಹೌದಾ? ಸೊ ಸಮ್ ಸಾರ್ಟ್ ಆಫ್ ಫೋರ್ಸ್ ವಿಲ್ ಬಿ ದೇರ್ ಇನ್ ಬಿಟ್ವೀನ್. Therefore, the total potential for this two system of charges, it is given by 1/4 pi epsilon naught q1 into q2 upon r12. R12 is the distance between these two charges. So the potential energy, it is electric potential energy. It is the work done in assembling this system of charges from an infinite distance from one another. ಇದೇ ತರ ಸಪೋಸ್ ನಿಮ್ಮ ಹತ್ರ 3 ಚಾರ್ಜಸ್ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ ಆಯ್ತಾ. ಸೊ ನನ್ನ ಹತ್ರ ಏನಿದೆ, ಒಂದು Q1 ಚಾರ್ಜ್ ಇದೆ, ಮತ್ತೊಂದು Q2 ಚಾರ್ಜ್ ಅಂತ ಇದೆ, ಮತ್ತೊಂದು Q3 ಚಾರ್ಜ್ ಅಂತ ಇದೆ. ಸೊ ವೆನ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ Q1 ನೀವು ಡೈರೆಕ್ಟ್ ತರಬಹುದು. ಸೊ Q1 ಚಾರ್ಜ್ ತರ್ಲಿಕ್ಕೆ ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. Q2 ತರಬೇಕಾದ್ರೆ ಆಲ್ರೆಡಿ Q1 ಇದೆ, therefore the potential due to Q1 ಇಲ್ಲಿ ವ್ಯಾಲಿಡ್ ಆಗುತ್ತೆ. ಪ್ಲಸ್ Q3 ಚಾರ್ಜ್ ತರಬೇಕಾದ್ರೆ the potential due to Q1 ಆಲ್ರೆಡಿ ಇರುತ್ತೆ, ಪ್ಲಸ್ potential due to Q2 ಕೂಡ ಬರುತ್ತೆ. ಅಲ್ಲಿ ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಎಸ್, am I clear? So for three system of potential energy, electric potential energy for 3 charges, it is given by, it is 1/4 pi epsilon naught into bracket Q1 Q2 upon R12 plus Q1 Q3 upon R13 plus Q2 Q3 upon R23. So this is for 3 system of charges. Yes, students. So for 2 system, it is 1/4 pi epsilon naught Q1 Q2 by R12. But this is for the 3 system of charges. So ಮತ್ತೆ 4th ಏನಾದ್ರೂ ಇದ್ರೆ ಮತ್ತೆ 3 terms add ಆಗುತ್ತೆ ಅಲ್ಲಿ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸೊ ನಮಗೆ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ 2 ಮತ್ತೆ 3 ಚಾರ್ಜಸ್ ಮಾತ್ರ ಇದೆ. ನೋಟ್ ಡೌನ್ ದ ಫಾರ್ಮುಲಾ. Electric potential energy is equal to 1/4 pi epsilon naught Q1 into Q2 by R12 plus Q1 into Q3 R13 plus Q2 into Q3 R23. Yes, don't play the session. If you don't want theory, we can go for MCQs directly. So theory gottilla andre question solve ಮಾಡಿ ಏನು ಯೂಸ್ ಇಲ್ಲ, because you need to understand. No? Just now we are saying this. Then electrostatic shielding. So what is electrostatic shielding? Now you can see the rainy season is going on. So rainy season ಅಲ್ಲಿ ನಾವು ಏನು ನೋಡ್ತೀವಿ, that is thundering we will see, then lightning process we will see. So during thundering and lightning process, here what happens, the excess charges from the clouds, it will be discharged to the surface of the earth here. ಹೌದಾ? ನೀವೇನು ಗುಡುಗು ಮಿಂಚು ಅಂತ ಹೇಳ್ತೀರಾ, during that process the excess charges from the clouds, it is transferred to the earth. So therefore human body is a good conductor of electricity. So ನಾವೇನಾದ್ರೂ ಹೊರಗಡೆ ಈ ಟೈಮ್ ಅಲ್ಲಿ ತಿರುಗಾಡ್ತಾ ಇದ್ರೆ, here what will happen, our body will catch those charges, so it will affect our body. For that reason, during the rainy season, during thundering and lightning, we are not supposed to go out of the house. ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ನಮ್ಮನ್ನ ನಾವು ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ನಾವು either we will stay at house, we will stay at the office, schools, building, ಯಾವುದೇ ತರ ಬಿಲ್ಡಿಂಗ್ ಅಲ್ಲಿ ನಾವು ಒಳಗೆ we will protect ourselves. So why we are doing this? Because so ಬಿಲ್ಡಿಂಗ್ ಯಾವುದೇ ನೀವು ಕನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ಐರನ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಐರನ್ ರಾಡ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ, which will help us, the excess charges will flow through the iron rods to the earth here. ಆಯ್ತಾ? So what you are doing here, you are protecting yourself from the electric charges by staying inside any of the building here. This phenomena is called as what? Electrostatic shielding ಅಂತ ಹೇಳ್ತಾರೆ. So this is one simple example. Now the process which involves the making of a region free from any electric field, it is known as what? Electrostatic shielding. So what is electrostatic shielding here? It is a process which involves making of a region free from any electric field, is known as electrostatic shielding. Yes. So free from electric field andre free from the charges. So charge electric field alla barutte. So you're making that particular region free from the electric field is known as what? Electrostatic shielding. Yes. Next, regarding the first part of this lesson, we have the last point here. That is the dielectrics, polar molecule, non-polar molecule, ಆಮೇಲೆ capacitors ಅಂತ ಬರುತ್ತೆ, which will end this lesson. Yes. What is dielectric? Dielectric is nothing but it is poor conductor of electric current. These are basically insulators and it contain no free electrons. So the dielectrics can be easily polarized when an electric field is applied to it, and thus their behavior in an electric field is entirely different from that of the conductor. So dielectrics andre conductors annak baralla, insulators annakalla, it is in between aita. So it is poor conductor of electric current. Here these are basically insulators and it contains no free electrons. These are called as what? Dielectrics. So dielectrics alli namatra ಎರಡು types ಇದೆ, dielectrics ಅಂತ. I think ನೀವು chemistry polar studied in the upcoming chemistry. Polar molecule, we will example nodu, water, Cl, N2, NH3, H2S, SO2, these are all examples for the polar molecule. So if we have the positive and the negative charges coincide, so in case ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ yes, polar molecule means what? That is the positive and the negative charges are separated by some distance is called as polar molecule. Non-polar molecule, if they are coinciding with each other, then it is called as the non-polar molecule. So non-polar molecule ke you will example nodabodu, CO2, CCl4, O2, nitrogen, hydrogen, methane, ethane. These are the examples for non-polar molecules. Okay. Then the next point we have, that is capacitors. So what is capacitor? Capacitor is a device which will store the charges. So capacitor andrenu, it is a device which will store the charges. Then what is capacitance? The capacity to store the charge is called as what? Capacitance. So capacitor ಅನ್ನೋದೊಂದು device ಆಗುತ್ತೆ which will store the charges. Capacitance andrenu, the ability of the capacitor to store the charge is called as what? Capacitance. What is the unit of this capacitors? The unit of this capacitor is, it is farad. Farad ಅಲ್ಲಿ express ಮಾಡ್ತಾರೆ ಆಯ್ತಾ. And the formula ನೀವೇನ್ ಹೇಳಿದ್ರಿ ಈಗಷ್ಟೇ, capacitor is a device which will store the charges ಅಂತ ಹೇಳ್ತಿದ್ದೀರಾ. ಸೊ ನಿಮ್ ಕೆಪಾಸಿಟರ್ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಅನ್ನ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ ಅಥವಾ ಈ ಡಿವೈಸ್ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಅನ್ನ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ? ಇಟ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದ ಪೊಟೆನ್ಶಿಯಲ್ ವ್ಯಾಲ್ಯೂ. Q is proportional to the potential value. Therefore Q is equal to CV ಅಂತ ಬರೀತಾರೆ. Q is proportional to V, or it is also written as Q is equal to C into V, or C is equal to Q divided by V. C is equal to Q divided by V. Q is the charge, V is the potential, C is the capacitance of the capacitor. Yes, this capacitance of the capacitor is also a scalar quantity. This is having a unit farad, or it is also expressed as coulomb per volt anta. The dimension formula ನೀವು ನೋಡಿದಾಗ m raised to -1, L raised to -2, T raised to 4, A raised to 2 ಅಂತ ಬರುತ್ತೆ. Yes, note down these points. ಸೊ ಈ ಅಕಾಡೆಮಿಕ್ ಇಯರ್ ಅಲ್ಲಿ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ಕೆಪಾಸಿಟರ್ಸ್ ಅನ್ನ ಡಿಲೀಟ್ ಮಾಡಿದ್ದಾರೆ. ವಿ ಹ್ಯಾವ್ ಓನ್ಲಿ capacitors in series, capacitors in parallel. Okay. The capacitance of a capacitor, the capacitance of a parallel plate capacitor, it is given by epsilon naught into A divided by D. This is when the free space is there between the two parallel plates. So capacitors and two parallel plates in the denote ಮಾಡ್ತಾರೆ ಆಯ್ತಾ. So when the air is there, so ಇದ್ರ ಮಧ್ಯೆ air ಇದ್ದಾಗ the capacitance of the capacitor is given by epsilon naught A divided by D. The capacitance of the capacitor ಅದ್ರ ಮಧ್ಯದಲ್ಲಿ ಯಾವಾಗ dielectric medium ಇರುತ್ತೆ, it is given by C is equal to K into epsilon naught A divided by D. K into epsilon naught A divided by D. This is when there is a dielectric medium in between them. C is equal to K epsilon naught A divided by D. Now, so when you connect two capacitors in series, right? So this is my C1 capacitor, this is my C2 capacitor connected to the battery. The capacitance of this capacitor is given by, so series aliddaga charge flowing through the capacitors will be Q. It is given by 1 by Cs is equal to 1 by C1 plus 1 by C2 plus and so on. ಇದು series ಅಲ್ಲಿದ್ದಾಗ parallel ಇದ್ದಾಗ ಏನು ಬರುತ್ತೆ ಅಂದ್ರೆ that is Cp is equal to C1 plus C2 plus C3 plus and so on. ನಿಮ್ದು ಎಷ್ಟು ಕೆಪಾಸಿಟರ್ಸ್ ಇರುತ್ತೆ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. Yes students, ಎಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಕ್ಲಿಯರ್ ಆಯ್ತಾ? These are the main points in this lesson. Electric potential and capacitance. Is it clear? I hope you have copied down the points and the formulas.